All right, we're going to go ahead and get started. Everyone, welcome. My name is Laurel Glenn. I am the new program manager for safety. If you've been used to Eric's face, we've got a new one this time. He has moved on into another position, but I will now be moderating these webinars. We appreciate you joining the webinar. Today's is on the impact of automated vehicle external communication on other road user behavior. I have had you all muted. You've come into the meeting muted, and we're going to appreciate if you stay muted until the question and answer session, which will be at the end. Captions are turned on for your convenience. Videos are going to be off during the presentation to maintain bandwidth strength. But if you have any questions during the webinar, please type them in the chat box and they will be addressed at the end. So at this time, I would like to present our presenters. So Alexandria Rossi-Alvarez completed an accelerated 5-year course of study in the Department of Human Factors at Embry-Riddle Aeronautical University, earning a BS in Human Factors Psychology, as well as a MS in Human Factors and Systems. Alexandria worked in Lextant from 2014 to 2018 as a senior human-centered design associate. She then received her ME in Human Factors Engineering and Ergonomics at Virginia Tech, and is currently, and only for about a week more, a PhD candidate in the Department of Industrial and Systems Engineering. Her PhD dissertation investigates how communication with vulnerable road users is affected when multiple SAE Level 4 automated vehicles equipped with external human-machine interfaces are integrated into urban traffic environments. So next Thursday, which is December 15th at 1 o'clock, this is just another little plug. Alexandria will be defending her dissertation, which includes 2 additional studies that align with the work that she is presenting here today. If you would like to join that presentation, there will be a link that I will send in the chat box for everyone if you decide that you do want to also attend that as well. All right, so now I'm going to go ahead and turn things over to Alexandria so we can learn about her investigation on how external communication on multiple vehicles will affect pedestrian decision-making in real-world complex scenarios. All right, Alexandria, take it away.
All right. Hi, everyone. My name is Alexandria Rossi-Alvarez, and I am a PhD candidate at Virginia Tech, working in conjunction with VTTI, and Dr. Charlie Clower is my advisor. Today, I'll be presenting one of my dissertation research projects, understanding vulnerable road user preference and interpretation of external communication with multiple highly automated vehicles. So 1.3 million people worldwide die because of road traffic crashes each year, and more than half of them are pedestrians, cyclists, and motorcyclists. In the last 4 years, pedestrians' fatality rates were reported to be the deadliest in 3 decades. And what many do not realize from just looking at these numbers here is that the consequences ripple far beyond the victims. It affects their families and friends who must deal with loss or aid in recovery. And as a society, we are actively living in the deadliest time period to be a pedestrian, which is a very scary reality. The Governor Highway Safety Association released new projections for pedestrian fatality rates for the first half of 2021. And in the first 6 months of 2021, drivers in the United States struck and killed 3,441 pedestrians. Unfortunately, this trend in this graph here is just continuing to grow. So concurrently, and it's not directly dependent, the rise in pedestrian fatality rates, there are breakthroughs in vehicle automation technology, and that's been skyrocketed over the last few decades. The advancements of technology has been developing in a volatile way, and companies around the world are competing to be the first to successfully create, develop, and integrate automated vehicles racing to be the first to breach this multi-billion-dollar space. This is happening right now, and we all have this rare opportunity to be living through these rapid changes. However, it is critical from a human factors perspective to proactively identify the weaknesses in the designs and areas of improvement to ensure that these technologies do not further contribute to the rise in pedestrian fatality rates. So this is the big question, why does examining current communication matter for the future? The communication pattern will change as AVs are integrated into the environment. With this comes the necessity to identify ways AVs can be effectively incorporated into our society. And one way is to understand the current flow and establish mental models of communication built from these patterns. Since fully automated vehicles are very much in the nascent stages of development, it's difficult to understand those unintended consequences. Therefore, looking from a human factors point of view and viewing those implications that will affect the communication pattern can help to, improve safety and promote an intuitive interaction. And then communication channels need to be created to connect vehicles and the surrounding road users. Designers and engineers are currently brainstorming ways to provide these cues to fill the void of that missing context. Some ideas to facilitate this are through the implementation of external communication displays, or EHMI. The development and testing of EHMI concepts are currently underway to discover which concepts allow road users to interpret the vehicle's intentions the best. Prior to this study, I conducted an extensive literature review in the area of pedestrian interaction with external communication on highly automated vehicles. We found that the vast majority of research in this area was based on subjective data and not performance-based. And most of this research, or a lot of the research, was being conducted in some type of simulated environment. And many of these studies focused on one vehicle within the pedestrian's vicinity. We developed a study that would objectively measure the interaction via performance and active decision-making. So this study includes 3 important areas that I would like to highlight. First, we wanted to include multiple pseudo-highly automated vehicles within the pedestrian's environment. Second, we wanted to observe real-time crossing decisions, which we were able to do on a controlled test track. Sorry, my screen went black for a second. And lastly, we wanted to understand participants' interpretation of the HMI from the perspective of a pedestrian and a passenger inside a vehicle. So for the specific analysis that I'm going to present today, we wanted to understand how many exposures to the HMI does it take for the participants to first notice the existence of HMI. Second, to understand the meaning of the different patterns being displayed with no previous knowledge of the system's existence. Lastly, once they understand the meaning of HMI, does it change their crossing decisions? So we tested 40 participants in a within subjects design. We defined highly automated vehicles as any level 4 plus system. And obviously these systems are not on the roadway, so we emulated this through some deception, which I'll go through in the next few slides. The light bar was altered between 2 locations, either in the windshield or in the grille, and between 2 colors, either white or teal. All participants experienced all 3 light patterns across every single trial and scenario, and I'll go through that in a little bit as well. And each participant viewed 8 different testing scenarios that were repeated for multiple trials. Participants experienced 4 scenarios as a pedestrian on the side of the road, and then they experienced 4 scenarios when they were a passenger sitting inside a testing vehicle. These scenarios included dynamic traffic scenes that were performed at the Virginia Smart Roads housed at VTTI. For our dependent measures, we looked at the number of glances that participants made to the automated vehicles in their vicinity for a specific trial, the distance between the participant and the vehicle when they decided to cross the street, how many times does the participant decide to cross or when are they making that decision, and the number of exposures it took for the participant to first notice that the EHMI on the vehicle and then correctly identify and interpret the pattern's meaning. So the study was conducted at the Smart Roads at VTTI. This is a closed test track research facility created in partnership with VTTI and VDOT. VTTI launched the Virginia Smart Roads. It's a suite of test tracks that enable advanced vehicle testing in a really comprehensive cross section of roadways. There are 4 major sections for the Smart Roads, which include a live roadway connector, the surface street, the highway, and then the rural section. This study was specifically conducted on the surface street expansion, which is pictured here on the slide. The surface street expansion specifically facilitates advanced automated testing in a really configurable environment, such as suburban neighborhoods and city intersections. The surface street provides us researchers and the users an unprecedented opportunity to study the challenging transportation questions, such as pedestrians, risk in urban environments. So again, we defined the highly automated vehicles as any level 4+ system. And as I said, these systems are not on the roadway yet. So we emulated this through some deception. So we had our drivers concealed in seat suits, which are imaged here. And at the end of the study, the participants were reconsented at the end and informed of the deception. We did a lot of training before we began collecting data, and we ran multiple pilots to ensure that the drivers were driving robotically and uniformly and just practicing all of the testing scenarios that we were evaluating. So we tested 3 light patterns that conveyed, I'm just going to pause this for a second. We tested 3 light patterns that conveyed vehicle intention to the pedestrian. So the first one here was, skipping ahead, sorry, let me go back. So the solid pattern here meant that the vehicle was actively driving. And then the out to in pattern, which will show up momentarily, there it is. This indicated that the vehicle was actively yielding. And then the blink right here, this indicated that the vehicle was about to start driving again. So I'll let this play one more time. So here, the vehicle is actively driving down the roadway. The out to in, the vehicle is actively braking or yielding. And this blink right here, indicating that the vehicle was about to start driving again. It was ready. So per the Virginia Tech IRB and VTTI Safety Committee, we could not have participants actually cross the street in front of the moving vehicles. So we utilized what we call our decision box. We set up a box outlined on the corner of the intersections, and participants stood outside the box, and the moderator provided instructions. After the scenario started, participants decided if they would cross the street by stepping inside the box. And when they would not cross the street, they stepped outside the box. They were allowed to make this decision multiple times after the scenario was started, and they were informed when the scenario started. So you can see here, there is the participant standing outside the box, and whenever they decide to step in, they stepped inside. So again, we had 8 different testing scenarios. The first 4 were pedestrian scenarios, and then the last 4 were passenger scenarios. The scenario groupings were counterbalanced to mitigate any order effects. And I'm going to go through each scenario individually. So our first scenario was a four-way stop where both vehicles came to the stop. Vehicle A approached the intersection first. Once the vehicles stopped, vehicle A proceeded straight through the intersection, and then vehicle B. The vehicles did follow all normal traffic laws that are on the roadway today, and participants were instructed that the vehicles would follow normal traffic laws. Scenario 2 is our right-hand turn scenario, where the participant is on the other side of the road here. Vehicle B is wrapping around and will make a right-hand turn in front of the participant. And then vehicle A here will just drive straight through the intersection once they've completed their stop. Scenario 3, the participant is on the other side of the road. Again, both vehicles will approach the intersection, and then once they stop, they will just pass through the other lane. And then lastly, we're going to move towards scenario 4. This was our last, I'm going to pause this really fast. This was our last pedestrian scenario. And this was our high-speed scenario where we had both vehicles driving down the roadway at 35 miles an hour. For this crossing decision, we decided to utilize Steve, which is this little guy here. He is this foam dummy that is on a RC pad, and we had our engineer trigger when Steve would cross. The participants were told that there was a bus stop on the other side that just is not in this drone footage here. Participants were told that Steve really had to make his bus, catch his bus that was coming, and he had to make it to the other side of the street. So participants indicated when they would send Steve or allow Steve to cross the street. What participants did not know is as the vehicles were driving down, one of the vehicles was going to quickly merge to the middle lane, which we'll demonstrate here. So that concludes the 4 pedestrian scenarios. And then we're going to move to the passenger scenarios. For the passenger scenarios, I'm going to pause the video. This maroon vehicle here was our testing vehicle. I was driving the vehicle, and then the participant was sitting in the front passenger seat. For the passenger scenarios, we wanted to understand do people notice and understand the EHMI from this different perspective? And how does that influence learning over time and their expectations of the external communication? As participants sat in the vehicle, they talked aloud about what they saw happening with the vehicles and with the external communication. Afterwards, they filled out a series of ratings, which are the same ratings or similar ratings, excuse me, that they filled out after the pedestrian scenarios. So this is our first passenger scenario. This includes our expert pedestrian, where we have our engineer who will actually cross the street after the 2 vehicles approach the intersection and come to a complete stop. As you can see, both vehicles are driving down the runway, approaching the intersection. They will come to a stop, and then we had our expert pedestrian cross. And then they will continue passing through the intersection. Our next scenario was a left-hand turn in front of the participant, where both vehicles again approached that intersection. Vehicle B proceeded straight, and then vehicle A made that left-hand turn after vehicle B has exited the intersection. Our third scenario was a construction zone. This was really to understand what are participants' expectations when there is a close call and a pinch point. So you're going to see here that there is one lane. The 2 lanes will turn to 1. the vehicles will approach the intersection and both go at the same time, or almost the same time. Vehicle B will stop for that yield, and vehicle A proceeds through straight, while the participant is sitting in this maroon vehicle watching this whole encounter, looking at the external communication and looking at the vehicle's behavior and talking through what they think is going on in these scenarios and if it matches their expectations. And then lastly, I'm going to pause this one more time. This is our last passenger scenario, and this was actually our ride-along scenario. So this scenario, participants actually drove in between the two automated vehicles. In this experience, they were still talking about the external communication, which is mounted on the front of the vehicles. Let me play this. All right. So the participant is in the middle here, and then the three vehicles will begin driving in a procession down the runway towards the intersection. Halfway through this drive down the runway, the pseudo-automated vehicle in the back will merge into that middle lane. And the front AV will stop brake a little bit because it detects Steve, and then continue towards the intersection. And this was to give participants experience driving with the AVs, as well as a different perspective of the interaction. All right, so next I'm going to dive into some of our results. And first, I'm going to start by looking at the crossing decision data by the specific scenarios. So participants' willingness and unwillingness to cross was analyzed across the 8 different trials utilized in the decision box. I think I forgot to state this, but those 8 scenarios that I just went over, they were repeated for multiple trials, so participants could have exposure to the different conditions that we were testing. Participants had a total of 18 different exposures to the system throughout that testing session. This is looking at those first 3 pedestrian scenarios where they were making those crossing decisions utilizing the box. So the first scenario was repeated 4 times. One of those scenarios was a baseline where the systems were off. And then for every single other scenario, they were repeated 2 times. The highest crossing frequency was for when there was 1 vehicle in their straight crossing path, trial 3 specifically, and for 2 vehicles in their straight crossing path at trial 2. However, the percentage of participants who were willing to cross the street, it was not statistically different across the trials. This graph here is the frequency of crossing decision by the light bar specifically. And among the conditions, the thin white windshield had the highest crossing percentage. However, the percentage of participants who were willing to cross the street, it was not, again, not statistically different across the different conditions tested. When we looked at them individually, there was the main effect of location did not significantly impact pedestrians' willingness to cross, and as well, the main effect of color did not significantly impact pedestrians' willingness to cross. So moving into if the participants noticed the patterns. Again, all participants experienced all 3 light patterns across all scenarios and trials. Participants were never provided information on the patterns, and participants were noted as successfully understand the patterns when they could discern all 3 patterns and their specific purpose. This graph here looks at the number of participants who noticed the patterns across all 18 trials that they had. And across these scenario trials, the percentage of participants noting the light bar, it was statistically different at different time points. We did run pairwise comparisons to understand where and exposures 1, 9, 17, and 18, those had significant pairwise comparisons, which that chart is included in the UTC report. So after we understand, did they notice the external communication on their own? We want to understand how many exposures it took for participants to correctly identify the intention of the light bars. And it took participants more than 12 exposures to the light bars to begin to understand what that pattern meant. After 16 exposures, the largest percentage of participants understood all 3 patterns. And at the point, it was only, at that point, it was only a little over half of the participants who were able to correctly interpret the meanings. So the percentage of learning, it was again statistically significant over the number of exposures, and we did do pairwise comparisons, which is also included in the report. And there were multiple factors that kind of aided in this, and I'll go through this in the main conclusions in a few slides. So the yielding and driver patterns were their first 2 patterns for participants to interpret. Some participants only noticed the yield and the drive pattern across the entire study. The ready pattern, which was that blink, that was the most difficult pattern and the last pattern for participants to understand. The pattern length was too short for participants to catch. Participants stated that it was difficult to pay attention, watch, and interpret the light patterns for 2 vehicles in their environment. Oftentimes, they had to prioritize their focus on the vehicle that they felt had the most risk to their crossing decision. Because of this, they would miss the light pattern on the vehicle because they would be turning their head back and forth to look at the other vehicle in their vicinity. And during this movement of turning their head or paying more attention to one vehicle, they missed that short ready pattern change. That just looks like a duplicate. So now we're going to move on, look a little deeper into this crossing decision. So for the first half of participants, they completed all of the pedestrian scenarios first, and then they completed the passenger scenarios. For the second half of participants, they completed the passenger scenarios first, and then they completed the pedestrian scenarios. And that's how we worked our counterbalance to look through or address any order effects. So this graph here looks at the participants who received pedestrian scenarios first, and then who received the passenger scenarios first. So to the far left here, this grouping here, these are the participants on average who never crossed. The middle, this is the participants. They did not cross the street when the vehicle was approaching. So when the vehicle was actively driving down the roadway, they would not cross until the vehicle came to a stop. And then the far right here, these are participants who crossed the street when the vehicle was actively approaching them. So starting with the far right here, so participants who experienced the pedestrian scenarios first made a decision to cross the street while the vehicles were approaching towards them. So this is that maroon here. And then looking at this orange, participants who experienced the passenger scenarios did not cross the street when the vehicle was approaching. They waited until the vehicle came to the intersection or came to their stop. So why are we seeing this flip here? The order that participants experienced the HMI and began to understand its meaning impacted their crossing decision. This was one of the only factors that impacted crossing decisions significantly. So tying this back to understanding the vulnerable or pedestrians' interpretation of EHMI from the perspective of a pedestrian and a passenger. So pedestrians did cross differently. There were more, participants were more conservative and cautious of the vehicles. The vehicles did not behave erratically. They were in the same locations. But one potential cause of this is the complexity that was tied to the passenger scenarios. So again, in those passenger scenarios, there were the two intersections. We had the construction scenario and the drive along. And the idea of necessity of the external communication and the purpose of the light bar really came up when participants were riding in between the vehicles. And one causation of this could be, since participants began to question the necessity of the lights early, it caused them to maybe doubt the validity of the system and begin to lose trust. So when they were asked to be a pedestrian and cross the street, they put that trust they put in the system, or they were more apprehensive about the system. So in addition to the objective data we collected, there was also a plethora of qualitative analysis that went along with this. And I'm going to just quickly dive into a little bit of the qualitative findings. So again, it was difficult for participants to focus on a vehicle's light bar when there were multiple vehicles fighting for their attention. Participants would often choose one vehicle that was in their immediate path and focus on it. Then they would change their glance to the other vehicle a few times to understand future action. However, again, when they looked back and forth, they often missed patterns being portrayed from the vehicle. Participants did express concern when both vehicles were crossing their intended path because they had to interpret the two light bars. And the light bar patterns were often not synchronized because, there may be completing different movements or it's not perfectly timing. And which is what will happen in the real world, right? Vehicles are not going to be synchronized in their movements. So because of that, and the viewing sequences, participants began to confuse the light bar patterns. With that, I already mentioned that complete patterns were missed by participants, specifically that ready pattern. Again, the location or the color of the light bars did not impact crossing decisions. Now, starting to look at just participant preference. So the light bar location in the windshield was preferred over the grille placement due to ease of visibility. Overall, the windshield conditions, they were preferred due to that higher placement. They were looking for a driver in the vehicle. There were no other distracting lights in that area. And again, it just allowed them, it was easier visibility. The color preference was nearly split between teal and white, with a few more preferring the teal. The white light really washed out depending on the amount of sunlight given that day. We did not run under rainy condition because of IRB and safety committee protocols. The light bars that stood out from the vehicle were preferred as they were more noticeable, specifically when the lights, if they were thicker or segmented versus a continuous light bar. So participants stated specifically that when AVs are first introduced to society, they want the light bars to stand out. However, over time, as they become more accepted or they begin, to understand the systems more easily, then they can begin to blend in. Participants thought that the light bars could be easily confused with existing surrounding lights on vehicles. And as a result, some thought the light bars provided conflicting information. So just if they saw maybe a white light on the vehicle, it might get confused with the accent lights on the vehicle. Nice. So that ends the analysis for Illusion 1. After we conducted this study, we did run a follow-up study, Illusion 2. I'm not going to be going over that one today. I will be going over that during my dissertation defense, but we did take learnings from this study and directly apply it to an additional study. I'd be happy to open for any questions.
All right, it looks like we have a question down in the chat box. It says from Bern Grush, have you considered matching sounds for the blind and for distracted pedestrians?
Yes, so that was one thing that did come up in the literature review, was the use of an audio component with EHMI. For this study, we did not use any audio. There are other projects that we are working on that is looking on an addition of audio, but not for this study specifically.
And we have another one from Matthew Cond. Did age affect interpretation of the lights at all?
So we looked across age, we looked across gender. We also had participants complete a tech savviness questionnaire and a risky driver questionnaire, as well as a risky pedestrian questionnaire. And we did not find any significant differences across crossing decisions.
All right, I have a quick question. Did the participants believe that the vehicle was fully automated, or did they not?
Yeah. All of our participants, the way we set up the study was really trying, when I met the participants, even before when we were doing recruitment and advertisement for the study, we were really, going home with the fact that these were, automated vehicles. When we were on the roadway, I was very, explicit with my directions that were giving to participants. I had this script that once we approached the intersection, that the participants, I would have to call to the control tower so they would program the automated vehicles to the right scenario. Once I said begin trial, you can go ahead and begin making your crossing decision. So it was really embedded. A lot of people, I only had one person begin to question the automated vehicles because they were extremely tall. So they were able to see the driver's hand on the bottom of the steering wheel, but I was able to convince them that it was just the vehicle mechanics turning the wheel. So, but yeah, all participants believed it. And at the end, I did reconsent and then inform them of the deception. And some people were not, they didn't believe me at the end. So
they didn't get to meet the cushions?
No.
No, okay. All right, we have another question from Carol Lau. Was Steve an adult or a child-sized dummy? And do you think the type of dummy would have affected the participants' decisions to let the dummy cross?
Yes, so Steve was an adult. We also do have child-sized dummies at VTTI, but we did not use them for this study. I do think the type of dummy would affect participants' decision. A lot of participants did not want to risk Steve's life. So that data is not included in the presentation. It is included in the UTC report and the published paper we will that we're planning on publishing soon. Participants were not willing to risk Steve's life. So like, nope, we're just going to wait for the cars to pass and send Steve. So they were very conservative about sending Steve.
All right, another question from Matthew Cond. What was the thought process behind teal as a light color besides any other kind of color like orange or yellow that is associated with hazards?
Yeah, so we worked on this study with industry partners, and these industry partners were really interested in white and teal. One of the conversations that our partners were having with their counterparts in Europe was Europe is really fighting for teal to be the AV color, and they wanted to understand, differences between white and teal. In Illusion 2, we looked at amber. That was one of the color that we did in Illusion 2.
Okay. A question from Peter Burns. While participants may not have believed an EHMI was necessary for these scenarios, how about other situations where communication might be needed?
Yes, I agree. I think there are situations where the addition of communication will be effective, specifically when you get to mid-block intersections, when you don't know what the vehicle's actions are going to be. And if you're looking for that driver to make that connection to understand, are they stopping? Can I jaywalk or cross the street? What can I do as a pedestrian? I see the necessity of EHMI there. For Illusion 2, our scenarios, we looked at intersection, and then half were intersection, half were mid-block crossings, because we wanted to understand when there's no indication of the vehicle's actions, do they rely more on the EHMI, or does that impact their crossing decision more?
Okay. A question from Rebecca Polinchak, and I apologize if I'm messing up your names. How about crossing at nighttime? Did you do any tests at nighttime or dusk or dawn?
For this study, we did not. For my third dissertation study, we did look at day versus night. But for this study, with working with IRB and safety committee, we had to stay during the day.
Okay. Just another follow-up from Rebecca. She says also that she heard that pink is a very easy color to see, especially at nighttime. So, and then also from her as well, can you change the colors and go from one color to another color for day or nighttime visibility? Like Christmas lights, how they change from whites to multicolored. So it'd be possible to have the lights change colors by any chance?
So what we're looking in my third study, here the color was consistent for the different patterns. In my third study, we were looking at different colors for each type of pattern. So for example, here we had yielding, drive, and ready. White was used across all three of those patterns, but the dynamic components, that's what indicated that pattern. In the other research, we looked at it the other way, where the pattern was indicated by a change in the color. There are other researchers that are looking at EHMI in this way, but for this study specifically, we were looking at the first way.
Okay. Question from Mario Sanchez. What is the status of legislation and standards regarding light bars? Do you know?
Yes. I am not very in depth on all the legislation. I know there are specific requirements through FMVSS when you begin to look at colors and patterns. Everyone is kind of diving into the research right now and trying to understand the interaction between pedestrians and other road users and other drivers to begin to make those strides in legislation. But I don't know any more about that status.
Are there any more questions? Okay.